Molecular formula and empirical formula is what we'll be dealing under this topic. Let's go. What is the empirical formula of a compound that contains 52.2% carbon, 13.07% hydrogen, and 34.73% oxygen? Now you have the molecular formula stated there. It's very simple. Let's go. Now all you need to do is construct a small table. You can see we have carbon, hydrogen, and we have oxygen. So you come to this place, construct a simple table: carbon, hydrogen, and oxygen. Now the next thing for you to do is for you to write their masses already given in the question. And so this is 52.2, and then we have the hydrogen is 13.07. That of the oxygen is 34.73. Can you see it? Now, the next thing for you to do whenever you immediately have studied this table is for you to divide by the atomic mass of the element. Divide by the atomic mass of the element. This is the atomic mass of the element already given. And so you divide this by 12. Divide this by the atomic number of hydrogen is 1. You divide it by 16, already given. Right? Good. Now, when you divide it, this will give you 4.35. This will give you 13.07. And this will give you 2.17. Right? Now, once you get it like this, the next step for you the next step you're supposed to do is you have to divide through by the smallest value obtained. Now, look at this value we just got. So, which one of them is the smallest value? Of course, it's this 2.27. So you divide by 2.17. You divide by 2.17. You divide by 2.17. Can you say beautiful? Now, when you finish dividing, here should give you 2. Here is 6. While this one should give you 1. Now, the question is we should calculate the empirical formula. Calculate the empirical formula. And please note this. The empirical formula of a compound is the smallest formula of the compound. And now at this question, the empirical formula is, you can see at carbon we have 2, hydrogen is 6, and oxygen is 1. Can you see? So it's simply C2H6O. And that is your answer under this one. That is all there is. It's so simple. Please endeavor. On my channel, I start with the simplest one and I progress to the more difficult one. Believe me, they are coming. The number 2, an organic compound has an empirical formula of CH2O and a molecular weight of 60. Give the molecular formula of the compound. Now, please note this thing. Note immediately that molecular formula is equals to empirical formula bracket N. And therefore, it means that N is equals to molecular formula all over empirical formula. This is the formula you need to use to solve this. Now, at the board, you have an empirical formula, and they have given you the molecular weight. And I can say that this is also the molecular weight all over the empirical weight. So write it down. Now from the question, we have the molecular weight, which is of what? 60, which is the same thing as the molecular formula. The molecular weight is 60. Now, we don't have the empirical weight, but we can get it. Because from the board, we already have the empirical formula. And the empirical formula is this already given, so I can actually calculate and get the empirical weight, or we can call it mass. Now, how can you calculate the empirical weight? You just come to this place. You have C plus hydrogen is 2 hydrogen here plus oxygen, right? I just separated this. Now I'll just substitute. The molecular mass of carbon is 12 plus hydrogen is 1 plus 16, the molecular weight of oxygen. Now, plussing them together, we have 14 plus 16. If you plus them together, that should give you 30. Right? Good. Now, if this should give you 30, this should give you 30. Right? Now, all you need to do is come to this formula, substitute it, and get your answer. Remember, the molecular weight is 60 divided by 30. Right? And that should give you 2. Right? Now, that means that your N here is 2. Right? Now, all you need to do is come to this formula, substitute it, and your answer flow naturally. Look at what I'm saying. You have the molecule, they want us to calculate the molecular formula, right? Now, we already know that molecular formula is empirical formula times N, right? Now, we know the value of our N. Now, all you need to do is molecular formula is equals to, your empirical formula is C2O. All in bracket, your N is now 2. Multiply that out immediately, and so you'll be left with C2H4O2. And that is the answer. So simple. Like I said, we normally start from the difficult one from the simplest one to the more difficult ones. So that is it for this one. At the number 3 example, what is the empirical and molecular formula of a compound that contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass? The molecular weight of the compound is already given. Now, you already know that we already ascertained that molecular weight is, we said it before, at the second example is empirical formula times N, or we say the molecular weight is equal to the empirical weight times N. We said it, we ascertained it. Now, we have to first calculate the empirical formula. Use the empirical formula to calculate the empirical weight. Divide it and then get your answer naturally. What am I saying? Of course, you have carbon, hydrogen, oxygen, right? And then you have 40, then you have 6.7, you have 53.3. Now, of course, you divide by 12, divide by their molar mass, 1, divide by 16. Then here should give you 3.33. This is 6.7. This should give you 3.34. Now, of course, you divide by the lowest of them here, the lowest, right? By the lowest ratio of the mole. So you divide by 3.33, 3.33, and then of course this place should give you 1. Here is 2, and then this place is 1. And therefore your empirical formula is C1 H2O1, which is equivalent to CH20. Now that is the empirical formula. Now we have to calculate the empirical weight, and therefore the empirical weight is simply carbon plus hydrogen. So we have 2 hydrogen here plus oxygen. And so all you need to do right now is carbon is number 12, this is 2, hydrogen is number 1 plus 16. And then when you plug them together, we did something like this even. We did something like this. You got 30, right? Good. You plug them together, this is 30. Now, the next thing we want to do is we want to calculate our N. Remember, we don't know our N. And with that N, we cannot actually solve and then get what we're asked to do. And so from here your N is your molecular weight all over the empirical weight. And so your molecular is 180 divided by 30. And therefore that will give you a value of 6. So if your N is 6, we can just come to substitute it here and your answer will flow naturally. Now, can you pause the video? Try to do it on your own. Yes. Now, we want to get the molecular formula. So all there is now is for you to just come here. I have to clean this part now. Remember, we said the molecular formula is the empirical formula times N. Therefore, the molecular formula is, what's the empirical formula? Empirical formula is C2O, right? What's your N? Your N is 6. Multiply everything out. So you have C6H12O6. That is the molecular formula. Of course, you know what that is. That is carbohydrate, right? Glucose. So, like I said, we're going to start from the easiest, and then we'll progress to the more hardest. The hardest ones. Now, of course, this is the part 1 of the video. Please search immediately the most important one. The part 2 of the video, the empirical formula when mass of CO and hydrogen is given. That is the part 2 of the video. Thank you very much.